We've got a second set of notes for the periodic table. This will cover everything that you need to know about the periodic table for this class. The first video watched kind of gave you a bit of an introduction, and you should know some of the terms that I'm about to talk about. But this is all of the information you need. So first off, we've got some geography of the periodic table. We got to know how we're talking about these. So we have columns and rows on the periodic table. The columns go up and down, and we call them groups or families. Families because they're pretty similar to each other as you look at the properties of those elements when you go up and down a row or a column. Going from left to right, you have rows, which we call periods. This is because the trends are periodic of the properties that we see as we go down the rows. So you may have noticed that when we talked about every 7 elements, the properties are periodic, they repeat. So that's why there are 7 periods, 7 rows. There are 18 families or groups, columns. It's also important to note that the elements are ordered from left to right and down by increasing atomic numbers. So it's like you'd read a book. You go to the first row and you read hydrogen is 1, helium is 2. Then you go to the next row. Lithium is 3, beryllium's 4, boron's 5, 6, 7, 8, 9, 10. And those atomic numbers go up by 1 each time. There are 3 main types of elements. We have the metals, which take up like 80% of the whole periodic table, this whole area here. The metals are shiny, they're ductile and malleable, they're good conductors of heat and electricity, they're often solids during room temperature, and they're found on the left side of this zigzag line. Okay. We also have the nonmetals, which takes up this space here. They're usually dull and brittle and bad conductors of electricity and heat. They're usually gases at room temperature, most of them are. And those are found on the right side of the zigzag line, except for hydrogen, who's over here all by himself. And then we have the metalloids, which are some really interesting elements. They have properties of both metals and nonmetals, depending on the temperature and the environment that they're in. And those are found around the zigzag line, right next to it. It pretty much makes a perfect zigzag, except for aluminum here that throws it off a little bit. Let's talk about the metals specifically. We have names for the different groups of metals. We have the alkali metals, which are row 1 here, except for hydrogen. When an alkali metal turns into an ion, each of those ions will have a +1 charge. That makes them very reactive. It's easy for them to react with other elements. Right next to them we have the alkaline earth metals, which when an atom of an alkaline earth metal ionizes, it has a +2 charge, which makes it slightly less reactive, but still overall pretty reactive. And we have this whole block in the middle, which are the transition metals. They have various ion charges and react in certain situations in different ways, depending on what they need to do at the time. There's some really interesting electron chemistry that happens there, but we don't need to get into that too far. We also have, within that group of transition metals, we have this extra inner transition metal, which we usually see at the bottom of the periodic table, but they actually belong right there. If you look at the back of the room, you'll see how it's actually laid out, but it's hard to fit that on a piece of paper, so they take that section out and put it at the bottom. These are the lanthanides and actinides. They're often pretty radioactive. And then we have all the other metals over here. And those also have various ion charges. This group right here usually has a +3 charge, aluminum specifically right here. The rest of them all kind of do a lot of weird things. We also have the nonmetals, which is almost everything except for the metals. These start with the noble gases on the right side. They don't really react with other elements. That's why they're called noble. Since they don't react, they don't turn into ions either. So they don't ever have a charge. It's just a neutral charge, or a charge of 0. Right next to them we have the halogens, which are super reactive. And they have a charge of -1 when they are an ion. Next to that is the oxygen family, which has a -2. Nitrogen family has a -1. Carbons can be +or -4. Hydrogen over here, since he's with the alkali metals, he's got a +1. But all the rest of those we just call the other nonmetals. They have different charges based on what groups they're in. And then we have the metalloids, which are found right on the zigzag line. They have properties of both metals and nonmetals and do a lot of weird chemistry things, but we're not going to go too deep into those. It's just important to know that they're between the metals and the nonmetals, both in their properties and in their location on the periodic table. Now, you've heard me say this word ion a bit. You should probably get a little background information on what that means. So an atom of an element is the smallest particle of that element that still has the properties of that element. It has protons in it, it's got neutrons, it has electrons. And in order for it to be an atom, it has to have the same number of protons and electrons. Because protons have a positive charge, and electrons have a negative charge. So if you have the same number, then the overall charge balances out, and that makes it an atom. Anytime an atom loses or gains an electron, it then has a charge because it has unequal amounts of protons and electrons. So if it has less electrons than it should, meaning it lost electrons, it has a positive charge because there's more protons. If it gains electrons or has more electrons than it should, then it means it has a negative charge because there's more electrons than protons. And we have each one of these element squares, which is kind of like the element's ID cards. It tells you everything you need to know about it for the most part. So each element has a square on the periodic table. These squares include the name, symbol, atomic number, and atomic mass of that element, of which we're about to talk about, using the example of hydrogen. So first off, we have the name of that element, and the name is hydrogen. It's right there. It's completely spelled out, usually capitalized in the first letter, and that's a pretty simple one. Then we have the chemical symbol, which is usually 1 or 2 letters. Well, it's always 1 or 2 letters. It abbreviates the name. Sometimes, like for tungsten here, it's W, but the word is tungsten. There's no W in tungsten. Sometimes they had different names back in the day and they changed them later but kept the symbol. It's kind of weird. There's just some research on it that's kind of cool sometimes too. But anyway, hydrogen here, its chemical symbol is just H, and it's a capital H, notice. If it has 1 letter, that letter is capital. If it has 2 letters, the first letter is capital and the second is lowercase. And that's how we know we're telling about different elements when we start combining them together. Now we also have the atomic number, which is always a whole number. It's how many protons an atom of that element has. So what makes up the identity of an element is how many protons it has. That's why each element has a different atomic number or number of protons. And then we have the atomic mass, which is kind of a complicated equation for the average amount of how much 1 mole, or 6.022 times 10 to the 23 particles of that element weighs in grams. It's usually a decimal of some form. So if you are looking for the atomic number versus the atomic mass, even though these are both pretty much 1, since this is 1.008, you know that's the atomic mass because it's not going to have 1.008 protons in the atom. And that is all for your notes. Hopefully that kind of helps a little bit. And with this information, you should be able to fill in your periodic table labeling chart here in the next couple days.